Welcome to Engineering Visualization channel. So today we are going to solve model question paper 4 problems. Okay, so watch the videos till the end. You can able to understand all the 4 problems. So each one of the problem I'm going to solve using solid software. Okay, all the 4 problems. So in this question number 1 given points and lines problem, second one is solids, third is isometry, fourth is development. So subscribe to my channel and share to your friends and classmates so that they can be benefited, and hit on the bell icon for the latest notifications and hit on the like button. Thank you all, and watch the video till the end. You can able to understand all the steps. Thank you all. Projection of point problem. Okay, this is a solid edge 2024 student version. Okay, first I'm going to draw an xy line. Okay, so we can make use of this video so that many of the students have been asked for the solving the model question paper of the CAD. Okay, for them I'm doing this. So guys, please make use of it. Okay, subscribe to my channel and share to your classmates and friends so that they can be benefited. Okay, so here with respect to the question here, so in the question what they mentioned here, so it is resting on the HP plane, say resting on the XY line. So you can see the question, a point A is on HP means it is nothing but the front view. That's why I have put a point and mention A dash. Okay, and now the length we should consider. So here the point, it is the top view lying in the first and fourth quadrant. In both first and fourth quadrant it is lying below the XY line. So that's why I'm drawing the length of 30 mm. So below the XY line. Okay, you can just see first and fourth quadrant, so it is below the XY line. That's why I am putting it and mentioning it as A. Okay, now after that see the question, you can change the thickness here. Okay, this is the new version of the software, that's why I'm getting a little bit of time because the commands were of different type. Okay, so if you want this software I can share this. Okay, this is the, for top A it is 35 mm drawn, and then if it is another point B is on VP. On VP means it is nothing but the on VP means it is nothing but the top view, and below HP. So below HP means we don't know how much distance it is. Okay, what they mention here, it is the line joining the front views makes an angle 30 degree to XY, while the line joining the top views makes an angle 45 degree with XY. So that means we should connect with the top views with an angle of 45 degree, front views with an angle of 30 degree. Okay, that's what given in this problem. Using this sentence we have to draw. So what I'll do is, here I'll be connecting the top views at an angle of 45 degrees. Okay, so from the top view I'll be drawing an angle line for a length of 45. So here just by randomly we can draw, and then we can change the angle here. Just first I'm drawing one line. Okay, and I can change the angle here. Can change the thickness. Okay, so select the line and select its thickness as 0.13. okay, now here I'll change the angle. Now you can see here I'll go to angle between. So before that I'll be drawing one smaller horizontal line here from at the top A. Okay, so go to angle between and select the angle between these two lines and angle you're getting in. Now we can modify, change it to 45. Yes, now it has been changed. Okay, this is what the top view connecting the angles. Okay, an angle of 45 degree. So you can see the question here. So another point B is on VP. On another point B is on VP means nothing but the top view, and it should be drawn on the XY line. Okay, so we know that the top views are connected by an angle of 45 degree. So from the top view of A already we have drawn an angle line at an angle of 45 degree. Now I'll put the point. So that top view we should be marking on the line passing the 45 degree and on the XY line. Okay, So the intersection of this 45-degree line and on the XY line. Now what I'll do is we'll be drawing another line which is of angle 30-degree. Okay, that is for front views like this. Yes, downward I'll be drawing it. So just randomly I'll draw it, and then after that I'll change the angle. Just randomly can draw here. Don't worry about the length. Now we can change the angle. So this angle should be 30-degree. Okay. Now you can see the top view on VP means nothing but the top view. It should be drawn on the XY line. Okay. Another point is on VP and below HP, and they have not mentioned any distances, right? So we can put the point here. Go to point and just change the thickness to 2 mm. Okay, and here I can put yes here. Now vertically downward is another point. Now we need to draw with the vertical line here. Yes, I can change the thickness of this line. So I'll be making it as 0.13 mm. Change it to 0.13 mm here. Okay, you can see here we should mention the points here. Okay, now mention the views here. So here this point is exactly B, small b, and this is B dash. You can see the top views are connected by angle 45-degree and front views are connected by angle 30-degree. Now we have to find out this distance. You can see what they mentioned. Find the distance of the point B from HP. Okay, so that distance we need to find out. So we just measure it using smart dimension. So that completes the problem, guys. Subscribe to my channel and like the video. So PQ given 85 mm long, has its end P 10 mm above HP, 15 mm in front of VP. The top and front view are given, that is 75 and 80 mm. Using this we have to construct. So initially I have drawn an XY line here, VP-HP drawn. Now we have to draw these locus lines. I'll be using offset command. So select the XY line and give the dimension 10 mm. In the same way again you select XY, give the dimension here 15 mm. Okay, now we can see that the apparent length given here. So apparent length okay, so this is we consider as a end points. Using this 75 and 85 mm, we have to draw the true length. First I'll be taking this apparent length in top view, okay, giving 75. So from this end I'll be drawing a vertical straight line. So from this end I'll be measuring for length of true length we have to give. Okay, go to arc by center, give true length 85 and cut the arc. Okay, because apparent length when it is rotated and projected we get the true length here. Okay, now you join from this end point to here. Okay, now at this end point of the line we can draw the locus line. So we can measure the length. It is 85, that is true length. So here at this end point you can draw the locus line. Same way the apparent length in front view dimensions we have to use. So the length given it is 80 mm, 80. Again go to arc by center and take the true length 85 mm. From the end points you cut the arc. And we join this cutted point with the end point, you will get the another true length. So here at the bottom below the XY line also we have to draw another locus line. Now go to arc by center. By measuring this 75 and 80 mm upper end lengths, you have to draw an arc to draw the upper end lengths. First select the 70 mm length, cut an arc. Same way for 80 mm length, cut an arc. Okay, now go to line and select thick line 0.50 mm thickness. So upper end length you always show with the thick line. Okay, now we can measure the lengths and angles. You can see this, that is the upper end length in front view 80 mm and upper end length in top view it is 75 as it is given in the question. Okay. And you can show the angles here. You can subscribe for the channel and hit on the bell icon for the latest notifications and share it to the maximum students so that they can be benefited. Welcome to Engineering Visualization channel. Today we are going to solve problem number 2 from projection of solid in model question paper 3 VTU computer aided engineering drawing. So I want you people to watch the video till the end so that you can able to understand step by step procedure how we are going to complete this projection of solids. In that we have the hexagonal prism problem with beta angle. Okay, so you need to follow each of the steps one by one. You can see in this video I am able to solve this problem within less than 15 minutes. Okay, so what is given in question? Hexagonal prism 25 mm side of base and axis 60 is resting on one of its edges of the base on HP plane. Draw the projection of the prism when the axis is inclined to HP at 45 and VP at 30 degree. That means angle of inclination in this problem they have given with respect to axis for both HP and VP plane. So that means it is an beta angle question. Okay, that means in this problem we need to find out the beta angle. Okay, first we need to, okay, in order to understand this problem completely and want to see the similar type of problems, okay, subscribe to my channel and hit on the bell icon for the latest notifications. Okay, now the same problem I'll take from the solution book like this. Okay, like this we need to construct in the solid software. Okay, why I'm completing this problem in solid software means, so 80% of your marks is there in the solid software, that's why I'm not doing the sketching. Okay, XY line it is written VPHP. Now we need to construct the hexagon using polygon by center command with respect to the edge here. So construct the hexagon, take smart dimension, give the length 25, it will change. Okay, now write the notation, top views and bottom view notations. Top views notations are written with ABCD and bottom face notations are written A1, B1, C1 like that, but it should be written within brackets. So here we need to find out the center of the hexagonal prism. So for that at least 1 or 2 lines need to be drawn, because since it is a prism, to find out the center of the axis no need to draw all the lines, and here inside of this hexagon we should be drawing the thin lines. No need to draw the thick line, thin line should be drawn here. 1 or 2 lines is enough. Okay, you can see in this problem I have drawn the 3 thin lines. Okay, since it is a prism, we should be drawing only the thin lines, not the thick lines, and mention O1 and close the bracket. Now draw the projection lines upward to complete the front view. So draw the projection lines upward here now. So axis of the prism, it is 50 mm. 50 mm length. Okay, enter. That is also 50 mm. So okay, so write the front view notations, so which are visible from the front view, so mention it. So from the front view, A dash, B dash and C dash visible, D dash, E dash and F dash not visible. So not visible means we should write within brackets. Same way for the bottom face also we write the same thing. So now we need to copy the same diagram using move command. Okay, and we need to incline with the base edge, so inclination to base edge is given. So actually they'll give angle of inclination to the axis, but we need to incline with the base edge inclination. Okay, it will be easy in order to do the inclination. So use the move command, creates a copy, slide along the XY line and go to rotate and take the base edge. Inclination, it is 45 degree, so incline 45, so it has been inclined. Okay, now extend the axis, find out the angle and project downward. To complete the second position, top view. So draw the projection line downward here. Draw the projection lines downward to complete the second position top view. Guys, subscribe to my channel and share to your friends and classmates so that they can be benefited, and hit on the bell icon for the latest notifications. Okay, write down the namings now. First I'll start from the bottom face. Now I'm writing for the top face, that is ABCDEF. Okay. Now first we know that to construct the second position top view, first we have to draw an outer boundary line. Guys, you can join to my channel by rupees 119 per month, and then you can cancel after the examination. Now from the top face it is visible, so complete the hexagonal face. It is visible from the top face. So drawing the hidden faces with the dashed line. Okay, finally there is an axis. You can join from O1 to O. So it is in beta angle problem. We need to find out the beta angle in this. So the procedure is simple. You need to draw an angle line first. So angle, it should be drawn for 30 degree. Okay, you can modify it just by doing like that. Okay, select this entire thing and then you can move it. First arc length of 50 mm we have to cut. Okay, 50 mm cut the arc. So draw the locus line. Now take this length of O1, 35.52. So cut this second arc length on the locus line. Then join using axis. Now we need to copy this second position top view and transfer using move command. Okay, project it upward to complete the final position. Thank you all. Thank you for watching the video. You can subscribe to my channel and hit on the like button and hit on the bell icon for the latest notifications. Thank you all. Thank you for watching my video. Complete the final position. Is placed coaxially on top of a regular hexagonal prism of base side 30 and height also out of the axis 60. That means first I should construct this hexagon. That is first I have to draw the orthographic top view. So remember it, for the polygons such as triangle, pentagon and hexagon, we should always construct the orthographic top view, because you require a box dimensions in order to construct it. Okay, change the dimension to 30. Now using this box dimension, okay, we have constructed the box. I have to show the box dimensions. Okay, so for the hexagon box with the box dimensions constructed, now I'll be constructing the orthographic of it. Take a reference line. Okay, so from this reference line, so construct a box for a length of 51.96. that is what the first length, 96, and angle 30 degree. Okay, the second length is 60, angle is 150. Again the length is 51.96, angle is 210. Okay, now join. So box it is constructed. Now we have to cut the arcs. Okay, for a length of 51.96 we will be cutting an arc of 25.98. Take the radius and cut the arc. The same way in the opposite side also I will be cutting for the same arc length. Okay, that is 25.98. Give the radius 25.98 and cut the arc. Okay. After that, at the edges we have to cut a arc length of 15 mm from the corner ends. Okay, 15 mm. From this side also 15. Cut it. Same way from here also. Cut it for 15 mm. Same way you can do it here. Radius of 15. Okay, now go to thick line. Now connect all these points. Okay, let's come to the bottom of the hexagon. Now we have to consider a vertical height of 30 mm. You can see 30 mm length of the axis. So height should be 30. First I will draw the vertical line from one reference end 30. Okay. We go to move command. It's a copy. Select the corner end and then place it with respect to all the corner points. Okay. By using continuous line, I want to join all these corner points. Okay, so that completes the hexagon. Now exactly at the center of it we have to place the cone here. Okay, so to place the cone here separately, what I'll do, I'll be constructing the hemisphere, that is ellipse of dimension 40 separately. You can see a right regular cone on base side 40 mm. Okay, on one side I'll be constructing by taking length. The length will be 40, angle is 30, and again length is 40, angle is 150, length is 40, angle is 210. Okay, good morning all. So in this problem, this is problem number 2 from solution book. So in this problem you have to construct a square prism of base side 30, axis length 60. Okay, resting on HP with all the vertical bases inclined to it. Okay, so we have to construct the development of this. Okay, first I will be constructing a square prism, okay, of dimension 30. So before that I will be drawing an XY line first. Okay, so here you can see I am drawing a square here, square of dimension 30 and angle 45 degree. Okay, you can show the dimension for one side, you can write the namings. So we have to write the namings in small case letters. Okay, So doing the projection line. So drawing the projection line here. Okay, the front view axis length it is 60 mm. It is a square prism, means we have to get a rectangular face in the front view. Okay, so the front and top view of the square prism. Front and top view of the square prism it is done. Now we can show the dimension. Okay, so now we have to draw the section plane which is there at a height of 50 mm from the base. Okay, and it is exactly cutting the axis at a height of 50. So for that I'll be drawing a 50 mm line from the base, exactly from the center on the axis. I'll be drawing another 50 mm line. Okay, so go to line. So from the bottom I am going to draw, that will be convenient. Okay, 50 minus 10, 60 minus 50 means 10, but I will be drawing from the bottom. Okay, so from the bottom 50 mm length. So I have drawn one line for reference, and then I am drawing a section plane. Taking this as axis plane, now giving the angle 60 degree. Okay, so that's what I can see, that angle of inclination will be 60 degree here. So type 60 and enter. Okay, so after this go to next and extend this line. Okay, this is where it is cutted. Okay, this is how it is cutted. Now we can show the angle for this section plane. Okay, angle of inclination it is 60 degree. Now we have to we can give the naming here. So that is 1, it is where it is cutted. Again on the A point it is 1, again here same on the A edge. Now 2, point number 2, it is falling on a vertical edge B. Okay, and then point number 3, you can see it is not falling on the C, it is falling somewhere in between B and C. Okay, somewhere in between. That's why I'll be drawing a projection line from this intersection of these 2 points. By projecting it, you can see this is not falling on the B, it is falling in between B and C. So that's why we have to draw another line here. I'll be making that line as a continuous line. So we can give that is 3, and here you can see again, if I write the point number 4, so that is not falling on the D, it is falling in between C and D. Okay, that's why point number 4. Then point 5, it is falling on the exactly on the vertical edge D here. Okay, now we have done with the namings. Now we have to project it. You can see that. So we have to project it. Okay, so so I can use the split command to highlight only the retained cut portion. Okay, so for that I'll be using the this split command. Using the split command we can split it exactly where we want to make the lines dark. Okay, we have to dark only the portions which has been cut by the section plane, the retained cut portions. Okay, so other lines I am going to make it thin lines. Okay, thin lines. By selecting it, by selecting these lines, I'll be making it as thin lines. Okay. Okay, now we got it, the cutted portion. Now we have to do the development. So draw the projection lines from here. Okay, so draw the continuous line here. Now we take vertical edge, because this is an parallel line method. This is a parallel line method because it is a prism. So draw vertical line. Anywhere you can take a straight vertical line. Okay. Okay, now here you can see the dimension, it is 30. Totally there are 4 faces in the sphere prism. So using the offset command, I will be giving the distance of 30, and then I will click for 4 times. Okay, I will get the 4 faces here. I'll make all these lines as continuous. Okay. Okay, now we can see by projecting the from point 1, so I'm getting point number 1 on AA. So, okay, so I can do that. So you can say first we have to write the namings A, B, C, D, capital A, capital B. So that indicates we'll get the exact vertical edges A, B, C, D, A. And now we can give the namings 1 and 1 we are getting on the vertical edge A. Okay. And the vertical edge B we having a point number 2, that also we can project it. Point 2 and 5 we are getting on the same point, but I'm not getting the intersection here, so I can use the split command here so that I can get the exact point here. I'll go to split command and split it exactly where the section plane is cutting. Okay, so now I'm getting the exact point. From here I'm going to project it